Hello viewers, welcome to yet another video on Analytical Instrumentation by Practical Ninjas. In this video, we are going to discuss about the Ultraviolet Visible Spectroscopy, also known as UV-VIS spectroscopy. When the ultraviolet or visible light in the electromagnetic spectrum passes through a sample or gets reflected from a sample, its intensity decreases. The measurement of this attenuated intensity is called the ultraviolet and visible absorption spectroscopy. This type of spectroscopy is useful for performing quantitative measurements. Qualitative measurements, however, cannot be effectively done with the help of UV visible spectroscopy. The basic principle of this absorption spectroscopy is the Beer-Lambert's law. The concentration of analyte or sample in a solution is determined by measuring absorbance of EMR at different wavelengths. UV visible spectroscopy helps in characterizing the absorption and transmission of different materials like pigments, coatings, windows, and filters. The light source used is generally a deuterium discharge lamp for measurements in the ultraviolet region and a tungsten halogen lamp for measurement in the visible region. Depending on the type of instrument, the dispersing material or dispersing body used to isolate the wavelength of light could be an absorption filter, interference filter, a prism monochromator, or diffraction grating. When measurement is done, utmost care should be taken to reject any stray light falling on the detector assembly. This stray light can affect the measurement values and induce errors in readings. The detectors used for measuring the intensity of radiations can be a photodiode, a phototube, or a photomultiplier tube, also known as a PMT. The available UV visible absorption spectrometers employ one or the following design strategies. A single light beam and sample holder is present with the facility for selecting a fixed wavelength for a range of EMR. A fixed wavelength or scanning type spectrometer with dual light beam and sample holders. A spectrometer with an array detector. Here, the measurement of absorption for different wavelengths is performed simultaneously. The first instrument that we will be studying is a photometer. The basic principle of operation of photometer is the Beer-Lambert's law. A photometer or a colorimeter is employed to perform quantitative analysis of a given analyte. The sample is normally in a liquid state. The sample is placed in a test tube, a cuvette, which is kept in the sample holder of the instrument. The measurement using photometer requires a standard reference sample. The concentration of the standard reference must be known. The readings for this standard are noted down as displayed by the photometer. Then, the unknown sample, that is, the sample under test, is placed in the sample holder and the readings for the same are noted down. Using the readings of reference and those of the sample under test, the concentration of a test sample is given as the test sample concentration equals the concentration of reference sample into the ratio of the test sample reading and reference sample reading. That's for this video. In the next video, we will be talking about the single beam photometer. Hope you like this video. To subscribe to the channel for such more interesting videos, do share and like and pass on your comments in the section below. Stay calm and keep learning. Peace out.